video we're going to focus on calculus, specifically optimisation. So this is where you need to find the second derivative of an equation to find the maximum or minimum. So in this example, an open top box needs to have a volume of 256 meters cubed. Find x and y, so the dimensions of the box, so that the least amount of material is required. So one way we can approach this problem is by using the volume and surface area. So we know the volume has to be 256, and we can calculate the volume doing x times y, right? Because that's the volume of the box. The surface area, we're not given a value for the surface area, but we want to try and find the least amount of material. So we want the surface area to be the smallest as possible. To calculate the surface area, we have the bottom surface, so x squared, and then we have x times y, but then we have 4 of them. So plus 4xy. It's an open top box, so there's no lid. So now that we have these two equations, we can rearrange the volume and substitute it in for y. So we have 256 equals xy squared, x squared y, sorry. And then we can rearrange it into 256 over x squared. Then we substitute y into surface area. So surface area equals x squared plus 4x, substituting y, times 256 over x squared. If we need to note up a little bit, we have x squared plus the x's cancelled, so we have 1 cancelled, and then 4 times 256, which is 1024 over x. So now we want to use the least amount of material required, so we can differentiate it. So surface area differentiated is 2x. So another way to write 1024 over x is 1024 x to the minus 1, right? Using laws of indices, that little minus means 1 over. So we have 2x, differentiating this, so minus 1024 x to the minus 2, because you minus the power by 1. So this is the equation for the gradient, and we want to find the stationary points where the gradient is 0. So we make this equal 0. So we can use a calculator, or we can just manually find the values for x. So you have 2x equals 1024 over x squared. I've just rearranged this. Then we can multiply both sides by x. And quickly use a calculator. So 1024 divided by 2. And then cube root to get rid of that 3. So you have x equals 8. Right, and we only have one solution. So because it's the least amount of material required, we also need to prove that using the second derivative. So second derivative is 2 plus, because minus minus, so 1024 times 2 is 2048 x to the minus 3. So in order for this to be the minimum amount of material, remember the minimum, the second derivative has to be positive. So if we plug 8 in, we see that our second derivative is 2048 over 8 to the power of 3 is positive, right? So that proves min. So we have a value of x, which is these dimensions. Now we need y. To get our value of y, we can just plug it in to the volume, or this one, because this was from the volume and this relates x and y. So if we plug in our value for x, 256 over 8 squared, so our value for y is 4. So if we have x equals 8 and y equals 4, the dimensions of that mean that the volume is 256 and the least amount of material is required. So if we do another example, a cylindrical can hold 1000 centimetres cubed of water. Find the dimensions and we'll minimise the amount of material needed to make these cans. So similar as before, we need surface area and volume. Given the volume is 1000, and we also know that the volume of a can is pi r squared, so the area of a circle, times the height. So it's pi r squared h. Surface area of a can, so we know the top and the bottom. So it's 2 pi r squared, 2 pi r squared, because you've got the top and the bottom. And then we also have the outer surface of the can. So you need the diameter to get the circumference. So, and we know the diameter is 2r. So the circumference is pi d times h. So pi d h. So if we rewrite it in terms of radius, we get 2 pi r squared plus 2 pi r h. And that's the surface area. So a similar thing as we did last time, we can rewrite the volume in terms of height. So height equals 1000 over pi r squared. I've just divided both sides by pi r squared. Then we substitute the height into the surface area. So you have surface area equals 2 pi r squared plus 2 pi r times by this, so times 1000 over pi r squared. Now we can cancel something, so we cancel pi and we can cancel one radius or radii. So surface area equals 2 pi r squared plus 2000, because we've got a 2 here, over the radius. So we now differentiate to find stationary points. So 2 pi times 2, 4 pi r, because we drop the power by 1, and then we differentiate this, so we get minus 2000 r to the minus 2. Remember how we rearranged it? 2000 r to the minus 1. So now we make it equal to 0 and find the value for r. So you have 4 pi r equals 2000 over r squared. If we calculate that, we have 2000 over 4 pi, and then we cube root to get 5.42. So that's the value of the radius. So now we differentiate the surface area twice, the equation of the surface area, to ensure that we've got the minimum, right? Because that's what it asks. So if we differentiate twice, we're just left with 4 pi, and then plus 4000 r to the minus 3. So if we plug in our value for r, we want a positive value, because it's the second derivative, and a positive value on the second derivative means the minimum. So if we plug in 5.42 to this, so 4 pi plus 4000, 5.42 to the power of negative 3. So that's positive. SA equals 37.69. So this is min. So now that we've got a radius, we want to find the height, right? Because it asks for the dimension, so we need r and h. We have an equation for volume here. So h equals 1000 over pi r squared. So h 1000 over pi times 5.42 squared. And we have our height. So with these two dimensions, we've got the minimum. If we do more examples, so we've got a length of wire, 12 centimetres, is bent to form a rectangle. Find the maximum possible area of the rectangle. So if we draw this out, we've got a 2D shape. So we've got well, it's a square, but pretend it's a rectangle. So the length of the wire is 12. So the length, that means the perimeter. So imagine we have x, y. So the perimeter is 2x plus 2y, which also equals to 12, because that's the length of wire we're given. So 2x plus 2y, which is 12, is bent to form a rectangle. Find the maximum possible area of the rectangle. So we know the area of a rectangle equals x times y. So we can rearrange this in terms of x or y. So if we have 2y equals 12 minus 2x, right? So I've just minus 2x from both sides, and then divide by 2 to get this. We now substitute y into this equation, so we have a equals x 6 minus x. If we expand brackets, 6x minus x squared, and now we want to differentiate the area and find a stationary point. So differentiated is 6 minus 2x. So we make that equal to 0. 6 equals 2x, x equals 3. So we have a value for x already. Now we want to find the corresponding value for y, but before we do that, we want to ensure that this is the maximum. So in order for it to be a maximum, the second derivative has to be negative, right? So if we derive it again, 6 disappears because it's a constant. Minus 2 times 1 is minus 2. 1 minus 1 is 0. X to the power of 0 is 1. So our second derivative is negative, which means this is the maximum. So we want to find the corresponding y value, plug it into this one. So 12 minus 2 times 3 divided by 2 equals 3. So